In this video, we're going to evaluate the integral of x multiplied by the square root of 4 plus x. And as always, there's a lot of times more than one way to evaluate an integral. Turns out that for this one here, you can use integration by parts. And that one's not too bad, not that long. You can use the substitution, and I think I did one similar to this. It was a different substitution, but it did involve the tangent. For this one, you can let x equal to 4 tangent squared of theta. And this is one where if you use this method, you'll have to this will transform the integral into one involving theta, and you would solve it like you usually do a trig substitution. You'll have to use a reference triangle eventually to get the answer in terms of x. But this is one substitution. This one gets a little bit longer than usual, but it works out. You can also let u equal to 4 plus x, or you can let u equal to the square root of 4 plus x. So that's 4 methods right there that'll work. Now the integration by parts, the only thing here is that the answer you get looks different than the other 3, but it's legit. If you take the derivative, you will get the integrand. And also remember that sometimes the author of a book, if you're working problems from a textbook, will give you the answer in a different form. In other words, if the original answer might be a sum or difference, and they might write it as a product. So it's going to look different than your answer. Now here, the method I chose was this. I let u equal to the square root of 4 plus x. So I want to transform this integral into one involving the variable u. So from here, then I squared both sides. I get 4 plus x. And then I take the derivative here. This will be 2u du. And the derivative of 4 plus x is 1. So it'll be 1x or 1 dx. I'll just put dx here. Now we're ready to transform this into an integral involving the variable u. So I'm going to need a replacement for the x here. We know that this right here is your u. We know that dx is 2u du. And then from this formula here, or this substitution here, I can rewrite that as u squared minus 4, subtracting 4 from both sides. U squared minus 4 is x. So now I'm set. I go back to the integral here, and for the x, I'm going to replace it by u squared minus x. Minus 4, I should say. There's u squared minus 4 here. And then, of course, this is your u, square root of 4 plus x. That's your u. And then the dx over here is 2u du. So then we just simplify. You got u squared minus 4 still. And let's multiply this right here. That'll be a 2 u squared du. And then we do the multiplication there. Got 2u squared times u squared. That'll be a 2 u to the 4th minus, and then 2 times 2u squared times minus 4 will give me an 8 u squared. That's du. And then we just integrate term by term here with respect to u. So for the first term here, I add 1 to the exponent, gives me a 5. That'll be u to the 5th, and you divide. So it'll be 2/5 here, u to the 5th. And then in the next one, minus u squared, add 1 to the 2, it'll give me a 3. So I divide, I get 8/3 u to the 3rd. And that's plus the constant of integration. And that's pretty much it as far as the integration goes. We simply now go back to the original variable. So the u is 4 plus x, square root of 4 plus x. We can write that as 4 plus x to the 1/2 power. So you put it in here where the u is and take it to the 5th power. This would be, again, 5 here multiplies in 1/2. So this gives me then 2/5. U is replaced by 4 plus x. and that's to the 5 halves power. And then it's minus the 8/3. Again, the u is replaced by 4 plus x. And this, again, u is 4 plus x to the 1/2. You cube that. That'll make this exponent 3 times 1/2 will be 3 halves. Plus the constant of integration. So final answer here then is 2/5 multiplied by 4 plus x to the 5 halves power minus 8/3 multiplied by 4 plus x to the 3 halves power plus the constant of integration. Thanks for watching. We'll see you next time.